This video will go over how to enter environmental measurement data into FUDSChem by uploading a CSV file. This data includes tests such as dissolved oxygen, temperature, specific conductivity, and pH. Go to Tools, Data Submission. Choose the correct project and event. Select Environmental Measurement as the data type. We'll go over how to create a CSV file, then come back here to click Upload File. Please note that entering the data through the interface is an option as well. Please refer to our Loading Environmental Measurements through the FUDSChem Interface tutorial video, linked in the description, for more information. Go to Reports, ADR and Submission Reports, Electronic Data Specification, Fixed Width, to look up what needs to be included in our file. Choose Environmental Measurement and click View Report. This report tells us field name, what needs to be included in the file. Data type, the type of characters the field will accept. This is defined at the bottom. For example, varchar is a variable character field that can accept letters and numbers up to the maximum length. VVL, whether the field requires a valid value. Required, whether the field must be populated or can be left blank. Column width, the number of characters to include in a fixed width file, which is also the character limit for the field. Start and end position, where each column starts and ends in a fixed width file. Description, what the field actually contains. For this example, we will enter our data in the CSV file. For the sake of time, we've already started to prepare one. To prepare this spreadsheet, we named each column with the field names listed in the data specification. Dist ID is a 5-letter code denoting what district you are in. The dist ID is just US plus the 3 letters that appear in the database dropdown after your district name. For example, the New England district would be USNAE. For the training database, it is USTRN. We'll get started with the location listed on the first page of our log, CRB-MW-467S. The next field is the log date, which requires a special format. The data specification shows that the date format needs to be DD-MMM-YYYY. So, we will enter 15-JAN-2023. Note that Excel tends to automatically reformat dates. To force Excel to use the format we need, we will select the Date column, right-click and choose Format Cells. On the Number tab, choose Custom. Type in DD-MMM-YYYY. The sample text above will show you the correct date format. Click OK. Note that if you close the file and open it again, Excel may reformat the date once more. To avoid this, you can leave the file open after saving it, even when you upload the file on the data submission page. That way, if errors are present and updates are needed, you can work on the already open file, thus avoiding having to reopen the file and causing Excel to reformat the date. We will only enter the final measurements on the log from when the well stabilized. So, the log time is 11:24. It requires an HHMM format, so we would need a leading 0 if we had an earlier time. We'll show how to do that later for our next well that has a time of 9:05. According to the specification, the matrix field requires a valid value. To look up valid values, go to Reports, ADR and Submission Reports, Valid Value Lists. Choose Environmental Measurement as the data table, and Matrix as the data type in the dropdown. Click View Report. We could scroll through to find the valid value that we need, or use the search up at the top to look for the value we need. We can see that the valid value for groundwater is Wg. In our Excel file, we will enter Wg for matrix. If you cannot find a valid value that you need, reach out to your Synectics point of contact, and we can point you to the right value to use or request that a new value be added to the list. SBD and SED, sampling beginning and sampling ending depths, may be listed on your log. In the case of groundwater samples collected from a well, the screen interval is preferred. In our case, the interval is not listed on the log, so we've had to look it up on the well completion diagram. In our case, the screen starts at 124.94 feet below ground surface and extends to 134.94 feet below ground surface. We'll set our beginning depth to 124.94 and our ending depth 134.94. Note that we could enter data collected for more unusual matrices such as animal tissue as environmental measurements as well. Depth would not apply to such a matrix, and in that case we would use 0.00. The analysis date and analysis time will be the same as the log date and log time, since the measurements were taken at the same time as the sample was collected. We would continue entering information in the file and looking up valid values as needed. For the sake of time, we've already looked up these valid values and know that the ANA-type, analysis type, valid value we need for temperature is TEMP. The data we will enter is the final measurement on the log in this last row, which is 10.2 degrees for temperature. As we're going through, we'll note that qualifier is marked optional. If needed, a qualifier could be added here. Otherwise, it can be left blank. The valid value list provides options for qualifying a value as estimated, tentative, or in need of attention by the PDT, for example. Remarks is also an optional field and can be used to clarify the sample test or add additional detail. We will populate it with the description clear. From here, we would start a new row for the next analysis, conductance. For the sake of time, we have a copy of the file where we've already populated the rest of the fields. We've also entered the data from page 2 of our example. Since the same analyses are completed at each location, once all ANA types are entered for the first location, it is easiest to copy and paste those rows and simply change the information that differs: loc ID, dates, parval, remarks. The last thing we need to do is make sure the time format for that second well includes a leading 0. To do that, select the log time and analysis time columns, right-click and choose Format Cells. On the Number tab, choose Custom. Type in 0 ####. Click OK. Note that if you close the file and open it again, Excel may reformat the time once more. Once we have entered the information and formatted it correctly, we will save the file as a CSV. Go back to the main FUDSChem window. Go to Tools, Data Submission. Make sure we have the correct project and event selected, then choose Environmental Measurement as the data type. Click Upload File, make sure the file type is CSV, and choose your file. Once it is uploaded, we will click the checkbox and choose Screen to make sure there are no errors flagged by the system. If there were errors, we would be able to click on the number of errors to view an error report. We would update the file, re-upload, then screen the new version. We address error troubleshooting in our Loading Environmental Measurements through the FUDSChem Interface tutorial video and our Screening Checks Overview video, linked in the description. As a best practice, we recommend using the file naming convention of datatype_site or event_timeframe. For this one, click Rename, and let's call it EMI_CampRichards_1Q2023. Click Save. Select the file and click Certify. This will send the file into the queue for review. Be sure to alert the reviewer that the file is available for them. For information on reviewing this data, please refer to our Environmental Measurements and Groundwater Levels Review video, linked in the description. Once you have certified the file, please be sure to upload the associated hard copy PDF documentation to the library and notify the appropriate user to approve the file. For more information on uploading files to the library, please refer to our library submission tutorial video, linked in the description. Don't forget to subscribe to the FUDSChem YouTube channel for more tutorial videos. All of the tutorials and playlists mentioned during this video are linked in the description below. Lastly, if you have questions or comments, feel free to contact us at fuds.support@synectics.net. Thank you.